Hello guys, as we can see here we have a D7 chip. We need to test the D7 chip. Why we need to test the D7? If we order from supplier a chip, we cannot put direct on the hash board. We need to test it because some of the chip it's not working, even if it's a new or second hand or something like this. So we need to test it. So how can we test the D7 chip? Before we resolder and we check and we will put on the hashboard. Okay, so as I know, there is a lot of the chip coming is second hand or it's not good. So we need to test the chip one by one and to check by using the multimeter and using by the power supply. So okay, let's draw the chip here in the big one. We know there is a chip, and here we have a positive and here is a negative. Okay, so we will put here the multimeter, whatever is red or a black, and also we will put the power supply here and we check the ampere for the ampere current for this chip. Okay. First we'll put the ohm meter. Let's start on this chip. No difference between the positive or negative or positive, whatever. Here, if I check here, we have 0.8 ohm, and after it's starting 0.0 and then 0.123 and then going to 0. So if I put continuity, for sure it should be continuity mode. Okay. So I prefer to work on the power supply. This is the power supply. I will inject voltage in this one. Okay. After I inject the voltage, I will see this ampere. It's showing if we have CC like short or it will increase the voltage. It will increase. Okay. So I will put the positive. I will use the voltage and I will put the positive and negative and we inject. I can use this one for electrodes. Okay, and just I will check and inject. You see? Okay, positive here, and I will inject. I will see the ampere is 0.669. Everything is good. 0.7. So it's working, and we don't have the short. Okay. Also 1.3 too much. Zero 0.5, yes. So it's important to check the chip. Why? Because if we order a new chip, okay, and this one chip we need to put on hashboard error. If this one is not good, then it's strange what's happened, because this chip is good. So it's really it's good to check before any install of any new chip. This positive, negative, 0.6, then 0.7, then 0.8, then 0.9. Perfect. Another positive, negative, 0.7, 0.8. Let's reverse the polarity, positive, negative. Starting 0.4, also good. Positive, negative, 0.7, 0.8. Perfect. And we know that chip is like 1,000 or 1 million resistance and capacitor, so it's a charge and discharge. 0.6. Now we have 0.6, 0.7. Reverse the polarity, positive, negative, positive, negative, and we have 0.2, 0.3, 0.35, as we can see. Okay, so it's good also. Positive, negative, 0.8, 0.9. Good. Reverse. Good. Positive, negative. If we have here positive, negative, here we have 0.8. 0.8. Yes, sir. Yes. Tell me. Positive, negative here. 0.7 also. Okay, and here also positive, negative. 0.5, 0.6. Okay, now I remove discharge. Okay, if I discharge, nope, just ohm meter, I will check direct ohm meter. 1, 2, 3. Showing 1.2, 0.9, 0.8, 0.7, 0.6, 0.4, 0.3, 0.2, and 0. That means perfect. It's a charge. Yeah, I mean, what's the charge? Charge is capacitor and resistance. It's charging, and after it's discharge, because I put like continuity, and the ohm meter, it will discharge the chip. So we have the 3 steps to check the chip. Number 1, the ohm meter without any voltage injection. Number 2, we have to inject the voltage. Number 3, we need to check the ohm meter to see if the ohm meter is going drop like degrees the voltage. Okay, so here I will put again. Let me check if you can see here. Okay, check here the ohm. Okay, I will put the voltage. First, remove the voltage. Let's check without anything. Okay, positive. We will forget about the polarity because we have just multimeter or ohm meter. 1, 2, showing 0.2, 0.4, 0.3, like this. It should showing near to 0. If I change to polarity, to continuity, sorry, it's beeping, right? Okay, here showing, because I charge, right? When I charge, it's showing 1.2. Now let's charge, because if we put continuity, it's like it's charging, right? Now I will charge this chip. I will inject voltage now. Forget about this. I will just put like 30 seconds or 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and I will remove. Remove. I will put ohm meter and I will inject. 1, 2, 3. It should like 1.8 starting or 1.7. You see? 1.8, 0.6, you see? 0.2, 0.2. Okay, this one is good. Also, let's try another one chip. I will inject the voltage. Showing 0.7, 0.86, 0.9, and I will remove. We'll put ohm meter. Testing. 0.7, 0.6, 5, 4, 3, 2, 1. Perfect. You see? Then 0. Okay, this one or this one is tested. Let's start here. Inject voltage. Turn off this one. Inject voltage. You can see, right? Inject voltage 0.9. Starting 0.9, it's a little bit high because it's detect. It should detect like 0.3, detect like 1.2 and direct to 0.7, 0.7, 6, 5, 4, 3, 2, 1. And after we can know which one is good, which one is bad. So this all chip, we have like detecting 4 chip not good and this one is good. Okay.